So we're going to talk about today some of the offsets, tool length offsets, tool radius offsets, corner radiuses, and some settings for those on the Hurco control. We get questions quite often on different things about our cutter comp and some of the settings for G41 and G42. And we also have some issues from time to time on tool length for some of the shops that may not understand that very well. They don't use it on other pieces of equipment or whatever. So I'm going to start with the tool length offset. I've got an NC program called here that is loading a G43 with an H value. For those that don't know, when you call G43, you are adding a tool length from a table. In this case, it's the tool offset or the tool length offset table, and the H value is the location on that table where it's stored. So when we typically do a tool setup in the Hurco control, we have this tool length calibration here that is set either through a probe or on the machine using a 1, 2, 3 block or something like that. But this is getting the length of the tool, and it is active immediately when the tool is put in the spindle. Now, all of our customers use this, but for conversational or NC, but some of them have a post processor that will post out that G43 with an H value. And what that's telling us is if we look over here to the tool offsets soft key, and this soft key is only available when you're in an NC program. It won't be there for conversational, it'll be grayed out. But if I click on that, you'll see that we come to the length offsets. What that H value meant was it's going to look in this location, location 23 on this table for the length. Now, this is where we've had some issues and a lot of questions. If there is a value here, even 1/10,000th of an inch, the control is going to use whatever is in this register for the length of the tool. If it is set to a 0, then the control will automatically revert to whatever is in your tool length offset or the tool cal length on the tool setup page. So we have a lot of customers who don't use that table ever, and someone will accidentally or on purpose, but they understood it and the next operator doesn't, will put something in that table, and then all of a sudden they have a program that ran all day yesterday crash today. And the reason oftentimes is someone will have inadvertently put a value in to a location that's being called. So we have a couple of options. That's either a training issue. There are lots of reasons, as many of you know, why we would want to leave that table active. One good example would be if I'm using, in this case, a 1/2 inch end mill, and I'm using that same tool to machine 2 different depths on some features or 2 different levels of a couple of shoulders or something, and they're very accurate or very high tolerance. One of them is fine, the other one is running a little bit shallow or a little deep. I can't make one offset that won't, because if I make just one offset like here on the tool length cal, it will change one and affect the other as well. So that might be an instance where we would call a G43 H23 and an H123 or something like that. So there are specific reasons why someone would want to use those. But in most cases, once you've called the tool number, you call the H value, it's the same and you leave it alone. So if the shop that you're in doesn't need to ever use these H values, you have a couple of options. You can strip that from the program, so the post will never post out a G43 with an H value. So you can change the post. You can go in and hand edit the code to remove that. That way it will never look at this table, and you won't have that problem because the call out for it won't be in the program. There's one other option, and it's not a permanent thing. We can turn it on and off. So if there ever is a need that you would want to turn this table back on, we can do so. But I can actually go in and turn this table off or disable it so it doesn't even exist. That way, someone can't accidentally put a value in there. So the way we do that is we're going to go to our user preferences. So that would be auxiliary on the machine, then the utility screen icon, user preferences. We're going to go to the NC settings. On this screen, we have disable tool length offset table. This is the first yes and no question on the parameters here. If I pull that down and go yes, it's going to alert me that if I hit OK, it's going to clear out that entire table all to zeros, and whatever's in there is going to be lost. Well, that's kind of what we want to do, so we're going to enter OK. And that has now disabled that table. If I go back to the tool setup and I go to tool offsets, tool length offsets over here on the soft keys, you'll see is grayed out. And we start with tool radius offset. So we no longer even have that table. So now if my post is posting that out, or for whatever reason, I don't want anyone to be able to enter a value in that table, simply turn it off and it's now no longer it's an issue. If I have a reason to turn it back on for a specific job, all I have to do is go take that parameter back to no, and it will reappear so I can use that table as normal. So that's pretty much it on the tool links. Those are pretty simple and straightforward, but being able to disable that and understanding why sometimes a job will run just fine for a while and then all of a sudden we have a problem, and it's usually because somehow a number has been put in there. So that's a couple of ways you can handle it, either through training or turning it off. Now, also in this program, we have a G41, also with a D value, it happens to be 23. Now, for those who are maybe new to NC or whatever, I'll kind of cover real quick. When we are programming in CAD/CAM, I've just brought up a screenshot here from Mastercam. But one of the settings is your compensation type. And we have three that people usually use. We have computer, control, and where. Other CAM systems will have the same settings. They may or may not be named the same thing. But basically, computer means we're going to post the program using we're going to offset for the diameter of the tool, half-inch tool, for example, but it will be in the code. There will be no way for me to adjust that. So the computer is taking care of it, and we're just assuming that our tool is exactly on size, and I have no control over that once the program is posted. The other one is control, and that's the example that we're using in today's example, where I have posted the program for a 0 diameter tool, for example, and then I put in my register the radius of the tool, and that way the control will offset by whatever value is in that table and be able to control it. I can make that number larger or smaller to adjust for wear or for size discrepancies. And the last one that is pretty common is the where, and that works the same way as the previous, the control does, where it puts a G41 or a G42 for cutter comp left or right, and a D value, but it kind of combines both computer and control. It will program as if we were using a half-inch tool, so the geometry in the program will be already offset, but it will give us the ability to add in the D register on this G41 line plus or minus a couple thou to adjust for wear. So those are the three settings that are most common, and probably the most common is the one that I've got highlighted there, the control, which is what I use today. And that is, it expects you to put in the full radius or diameter, depending on the control that you're on. But on Hurco, it's a radius of the tool. So if I were to bring my program back up, and this is just a simple frame, I'm going to show that in graphics. The way I have it right now, there is no cutter compensation whatsoever. So it's expecting to find a value in the G23 line, and there is nothing there. So the center of the tool is following the exact cutter path. If I go back to my tool setup, and I go to the tool offsets page, I'm on the radius offset. If I put here in 23, a 1/4 inch, which is half inch, of course, and I run that, you'll see that now the tool is being compensated for and the center of the tool stepped over. Pretty simple, pretty common. Most everybody's aware of this, not everybody, so I wanted to kind of begin here at the basics. And if I needed to adjust for cutter wear, deflection, maybe the tool's not exactly a 1/2 inch, whatever, then I would go to that register and I would adjust this by a couple thou here or there. This works the same way with wear. If you had programmed it for wear, it's just with this set to 0, I would see my tool would be accounted for, then I could add to or subtract from that. So that's kind of the basics of how that works. Now we have a couple of other things we can do as well. Sometimes we're able to have 9,999 tools in our library. And sometimes people want to use tool 900 and they want it to be offset 900 and they want to be able to control it that way. Well, obviously our table only goes up to 200, both for length, radius, and corner radius. So if you have tool 900, you have no way of calling a D900. So if you want to be able to do that, there is a way that we can use this diameter value right here on the tool setup page, and then use the diameter wear, if we choose to adjust that. So the way we do that is on the same screen or the same user parameter screen. So I'm going to auxiliary, utilities, user preferences, NC settings again. And we have this bottom one here that says diameter compensation using tool setup. If I answer that to yes, if I call a G41 or a G42 in the program with no D value, without the D value, then it will default to using this diameter here. So if I go into my program and I'm going to get rid of that D23, I'm going to go down and run this. Let me go back and zero out our table, make sure we did. So for tool radius offset, so we're at 0. But if I draw that, you'll see that we are still compensating for the tool. If I go back to the tool setup and I make this 1 inch, for example, note our distance here. If I rerun it, now we're compensating for the larger tool. So that does affect without the D value. If I were to put the D value back in, then it would use the register. So if you set that parameter to yes, then you have the freedom to use it or not, depending on what you want to do. Now also, if I'm using this diameter field here, so 0.5, then I can, if I don't want to change the actual diameter, if I'm calling this a 1/2 inch diameter, and I want it to show up in my matching or whatever, and I don't want to affect the actual diameter of it by making it 497 or 501 or whatever, then I can use the diameter wear field to adjust this. So if I were to put 2 thousandths or 3 thousandths in here, plus or negative, then it's going to adjust the size. Now I will caution you on the diameter wear, when you highlight this field, it tells you down here what's going to happen. A positive value will decrease the diameter of the tool. A negative value increases it. So it's basically just the opposite of what you would normally do either here on diameter or in the tool length offset screen or tool radius offset screen or in any other control really. Engineering thought of this as a wear, so it's kind of just a little backwards, but we did get them to put the description down here so you could read that before you make an adjustment. So basically if I put a negative 2 thousandths in here, it would be just like changing this to 0.502. It's the same concept. So that is the G41, G42, and the tool radius offset screen. If we look at the other screen here, or the other offset, we had tool length, which we covered, we had tool radius. Now let's call the tool corner radius screen. Basically, this is working, for example, we have a ball nose end mill, or we have a bull nose end mill. We want to be able to describe the actual corner radius. The reason we might do that is because the control is capable of 3D cutter comp. So bring this up here. In 2-axis, 2.5-axis machining, we really don't have that big of an issue. We don't really have much to worry about. And a lot of times in surfacing, we don't either. But let's say that for whatever reason, we need to be able to control the diameter or the cutter comp or wear on something that's pretty precise. I need to hit it exactly. Well, then I am able to adjust that corner radius as well. So the way we would do that, your post processor would have to be set up to do that. And we would call a G41.2 in the program, as you see here. Then it's going to call both a D and an R. Now, in this case, we can't use the D in the tool setup. We would actually have to put a D in the program and use the tool radius offset for our G41 cutter comp left here. But we also have the R value, and the R value is what correlates with this table here. So if I were to call D23, that would be where I'd put the 1/4 inch in for the radius of the tool. And then I go to the corner radius, and let's say this was a bullnose end mill with a 30 thousandths or 60 thousandths radius on the corner, I would put 0.06 here. So now, when the control sees that, it will know to look here for the diameter on the D register and on the R registers for the corner radius. And then the rest of the information that it needs will be in the code itself. So in this example, we've got a tool tilted. This is obviously would be on a 5-axis machine, but it doesn't have to be. You're going to have an IJK and a UVW. And that's getting a little more complicated. Again, all done with the post processor. But basically what it's doing is telling that what is the angle of the tool with the IJ and K. The UVW is telling it from the center of the ball or the center of the radius, whether it's the center of a ball nose or the center of a bull nose, if we had a bull nose here, in what direction is it to the contact point, which is that little blue dot there. And then the XYZ is actually controlling the contact point. So basically, whether I have, in the example up here, we broke a tool, it was a late Sunday night and I broke a tool, and that was the last 1/2 inch ball nose I had, but I got a couple of regrinds that are a little bit smaller, then this would come into play and would allow me to use that other tool. Also would allow me to measure my part or my surface and find out that I need to adjust the diameter of, or the contact point a little bit. I can do that as well. So that is something that a lot of people is not aware of that we have, and it can be pretty powerful if you know how to use it. So I'm going to open up here for questions. That kind of covers everything in how to use these offsets. I really don't have a whole lot more to add. There's just some controls there for turning things on and off that a lot of people aren't aware of, and we do get a lot of questions on that, especially how do I control the diameter on a tool that's called, tool 500 or whatever. I have all my end mills set up as 500 series, and I need to be able to do that. So that's one way to control that. Turning on and off the tool length offset, that's a big one for a lot of shops that don't do NC all the time, or they have some less experienced operators. That means you only have to focus in one area for tool length, and that's on your tool offset page or tool setup page. Stripping that G43 out of the program is another one. So I've got the chat window open here. I'm going to look through and see if well, I don't have any questions at this point. If you guys feel free to unmute yourself also if you want to ask a question, or you can type it here in the chat section. All right, so far nothing's getting typed in. Okay. We'll keep waiting here a few seconds, but hopefully that helped a little bit. with some of the questions. This wasn't a very long webinar today. Really wasn't a lot to be able to talk about other than just those few little settings. Everything else is pretty straightforward. Here we have one. Actually, let's see. All right, so we have one of our sales reps is on, and he said last week that he had a question on importing and exporting the tool data between a conversational and NC program. It was pretty cool. It worked. Can you review that? Gary, can you put a quick note up there what you mean? Are you talking just about exporting or saving the NC states file, or what exactly? I will, while I'm waiting on Gary to type that in, I will mention, if we go to the input screen here, we have this little button here called ImportExport Functions. And if you click on that, it will give you the ability to export to a thumb drive or to a network or whatever, your entire library, or just the NC states file, which includes your tool setups and your part setups, like your G54 through 59 and so forth, or the entire library, and then you can export those in from those sources as well. So if I wanted to take it from one machine and put it into another, I could do that. All right, import conversational tools to use in an NC program. I don't know if I can import. Gary, you might have something there that I'm not aware of. I can do the NC states file, or I can import from one conversational to another, but importing conversational tools to use in an NC program. If you feel comfortable, would you want to unmute and kind of tell the group what you learned? Now, we might all learn something there. All right. Well, I'll have to get some more information about that from Gary and see if we can put something out. We're going to send everybody a link to download this who has registered. So if anybody wanted to see something or show somebody else, you'll get a link for the video recording, and also those who registered that didn't make it on there with us today, they'll get a recording as well, or a link for the recording.
Hi, Mike. This is Gary Kittredge. Can you hear me?
Gary, how are you?
Very good. Yeah, so it's right there. That's a function number 1, import from a conversational file.
Oh.
And it was really pretty cool. We brought in a NC program, and a new operator didn't want to have to redefine his tools or figure out to use tool length offsets and all that. So we and it worked. It was the first time I tried it, but you know, hats off to Hurco. It worked.
Well, so, yeah. Thank you. I actually have never noticed that button there, nor have ever had a need to do that. So thank you for unmuting and telling us that. That's cool. So from I've always seen I can import from one conversational to another, but I've never had the need to do this, so that's good. So that would be really good for someone who doesn't have a library then.
Correct. He did not have a library.
Okay, that's probably why that got added. Yeah, for those of you who may not know, if you don't have the tool material library and you create conversational programs, a new conversational program will not have any tools associated with it. You will have to either import those in from another one or recreate them. And if you switch over to an NC program, that uses an entirely different set of tools than the conversational. So there was two sides of the control. Tool 1 on the conversational might be a 1/2-inch end mill. Tool 1 on the NC side might be a 2-inch face mill. So they're very different. So if you don't have the library, then this would be a way for you to import from conversational files to NC. With the library, however, tool 1 is the same no matter what. So that's good. I didn't even realize that we had that. So thank you, Gary.
Yep. And Mike, see the comment there from Dean Allen.
Yeah,
he also discovered the same thing.
He says that I create a conversational program with nothing except the part setup, then open the NC file, and then import the conversational program. Okay. Yeah, so these imports, again, that was off of the input screen. So if you hit the input button on the control, you'll have the F5 key here is ImportExport Functions. You'll be able to click on that, and then that gets you to these import and export fields here, which can be pretty handy, especially if you want to move tool libraries and so forth between machines or to your desktop software if you have that, or now we know if it's a good option if you don't have the library. All right, very good. So we had one that says most of what you're showing us is related to ISO programming, correct? And that's true. We have, for those who don't know, we have industry standard NC, which is pretty much FANUC style programming. It's the same code you'd see on any machine almost. And then we have Hurco basic NC, which is a little bit different. Cutter comp works pretty much the same way. The difference would be if I call a G41 with a D value, if that D value has a decimal point, then the control is going to use it as the diameter of the tool. Not the radius, but the actual diameter. If that D value has no decimal point, then it will use the table for the tool radius offset table. So it gives you the ability to call that diameter within the program, but then the code is not standard. So what we talked about today, being able to leave the D out and then use your tool setup, is probably a little bit better option for that, but that's really the only difference if you're looking at Hurco Basic versus Industry Standard NC. All right, well, I don't see anything new coming in, so I'd like to thank everybody for taking time to be with us today. I'll go ahead and stop the recording here.